Hello friends, welcome to State Engineering Service examination section of Winds of Change. We will cover so many questions from the civil engineering topic here from expert IES. You may contact us at windsofchange2020@gmail.com, and for the study material you can download from the link given in the description box. You can subscribe to this channel to stay updated for more videos. You may like these videos if you feel useful for you and comment for any feedback. Welcome to the first video of 120 questions of highway and traffic engineering. In this video, we will cover question number 1 to 30. So let's begin with the first question. Tie bars in cement concrete pavements are at expansion joint, contraction joints, warping joints or longitudinal joints. So where we provide the tie bars in cement concrete pavements? Just think about it. Tie bar connects the two units of concrete pavement. Now, which are the two units? It will be along the longitudinal direction. Here, the tie bars are provided for the longitudinal joints. You can see the longitudinal joints here. These are the longitudinal joints along the length. You can watch it. These are the cells, different units of concrete. Usually this length is 4.5 meter. This width is approximate width of a single lane. So to join these cells from each other, we will provide tie bars for the longitudinal joints and dowel bars for the transverse joint. These are the transverse joint. Okay, so please memorize it. It is very important. Next question. The fundamental factors in the selection of pavement type is climatic condition, type and intensity of traffic, subgrade soil and drainage conditions, or availability of the funds for the construction project. Just think about it. The main factor which is responsible for the selection of pavement type, that will be what will come into the picture first. If we think about climatic conditions, subgrade soil, fund, these will come afterwards. First of all, there will be the type and intensity of the traffic that will flow on the pavement that will be constructed. So that is why first of all we will look upon type and intensity of traffic. Okay, so option B will be the correct answer. What are the other factors that affect the selection of the pavement? This is availability of fund also, subgrade soil and drainage condition also, availability of construction material, availability of equipment, labor, atmospheric condition like rainfall, snowfall, temperature, time availability, as well as the topography or level of the area above MSL, that is the elevation of the land. Okay, so these factors should be kept in mind for selection of the pavement type. Next question. The entrance and exit curve of a rotary have equal radii and equal width of pavement, equal radii but pavement width is more at entrance than at exit curve, or equal pavement width but radius is more at entrance curve than at exit curve, or different radii as well as different width of pavement. Just think about the condition of a rotary at entry and exit curves. They will be having different width. It's obvious, because it will depend upon the design criteria, and they will be having different radii also. So that is why option D will be the correct one. Here you can see that this is the exit width, this one is the exit width at the rotary, and this one is the entry width for the rotary. So these both widths can be different. This will be dependent upon the traffic condition as well as the design criterion. Now this radius of this entry as well as this exit radius, these two are different. These two will be having their own values. It will depend upon the traffic as well as the topographic condition of this area. Okay. Next question. The particular places where pedestrians are to cross the pavement are properly marked by the pavement marking known as stop line, turn marking, crosswalk line or lane line. Just think about it. This is very easy question. The pavement line which is responsible for pedestrian crossing, that will be known as crosswalk lines. Okay, we all know about the crosswalk line. It is very easy to answer it. These are the crosswalk lines which are provided near any intersection for the crossing of the pedestrians. Okay, next question. The camber of shoulders in waterbound macadam road is equal to the cross slope of the pavement, less than the cross slope of the pavement, or greater than the cross slope of the pavement, or 0. We are talking about the camber of the shoulders. Usually we talk about the camber of the pavement. Here it is being asked about camber of shoulder in case of the WBM, that is water-bound macadam road. Can you guess it? It is equal to the cross slope of the pavement. This is the cross slope of pavement, and the shoulder is also designed at this camber only, which is for the pavement. Okay, so this is the case of the water-bound macadam. You can watch this picture also. It is very important to memorize the picture of water-bound macadam in your mind. Next question. If aggregate impact value is 20 to 30%, then it is classified as exceptionally strong or just strong, or satisfactory for road surfacing, or unsuitable for road surfacing. Just think about it. Aggregate impact value of 20 to 30%. This is a high value of AIV. So classification will be, do you know about it? Okay, it will be satisfactory for road surfacing. 20 to 30% will be only satisfactory for road surfacing, and we should memorize it. It is very important to memorize. Exceptionally strong, the first case, it was for the AIV value of less than 10%. Okay, and for strong it should be 10 to 20%. For satisfactory we have already discussed for 20 to 30%, and weak for road surfacing, that is unsuitable for road surfacing, it will be more than 30%. So this is also an important question sometimes asked, that after which value of AIV it is unsuitable for the road surfacing. So it will be 30%, means maximum value of AIV that can occur, that has to be 30%. Okay, next question. In CBR test, the value of the CBR is calculated at 2.5 mm penetration only, 5 mm penetration only, 7.5 mm penetration only, or both 2.5 and 5 mm penetration. So I think this is the easiest question of highway engineering. In CBR test, what are the penetration values? That is very easy to answer. We all know that CBR value is tested at 2.5 and 5 mm penetration. We have the standard value for these, and we find out the percentage or the ratio of it with the standard value. If you want to go for CBR test properly, then you can visit to our revision video of pavement material and design of pavement, the link of which has been given in the description box. You can visit there, or you can download our app of Winds of Change. There also you can find these videos. Next question. The provision of the traffic signals at intersection reduces right angle and rear end collision, or increases right angle and rear end collision, or reduces right angle collision but may increase rear end collision, or reduces rear end collision but may increase right end collision. Just think about it. What will happen in case of the traffic signal at intersection? Think about it. First of all, it will reduce the right angle collision, because one traffic coming from this direction, another traffic coming from this direction. So this right angle collision will be very much reduced in case of the traffic signal, because when this traffic will stop, then only this traffic can flow. Okay, and there will be chances that it may increase the rear end collision. Okay, so answer C will be the correct answer here, that is it reduces the right angle collision but may increase the rear end collision. Let's find it out how. These are the right angle collision that can occur, which we have already discussed. These are being reduced in case of the provision of signals. In case of rear end collision, that is when there is change of the light, there can be a possibility that this vehicle stops and this vehicle may hit it if it is not being capable of stopping into the time provided by this vehicle. There could also be a possibility of left turn provision, which is also being avoided in case of the signalized intersection. Okay, next question. Highway facilities are designed for annual average hourly volume, annual average daily traffic, 30th highest hourly volume, or peak hourly volume of the year. Now highway facilities are designed for which of these? Think about it. This is a very important question, that at which traffic volume we will design the highway facilities. The answer will be option C, that is 30th highest hourly volume. We will design at 30th highest hourly volume for highway facilities. This is also called design hourly volume. This is being explained in the video of revision of traffic engineering. You can go to this video through the link given in the description box. We are moving further to the next question here. As per IRC recommendations, the maximum limit of super elevation for mixed traffic in plain terrain is 1 in 15, 1 in 12.5, 1 in 10 or equal to the camber. Just think about it. Maximum limit of super elevation in plain terrain. You may know the value of rate of change of elevation, maximum value, that is 7%, that is 0.07. So the answer here will be option A, that is 1 in 15, approximately 1 in 15, because 7% is 1 in 14.3, which is being written as 1 in 15 here. Okay. Next question. If B is the wheel track of a vehicle and H is the height of center of gravity above road surface, then to avoid overturning and lateral skidding on the horizontal curve, the centrifugal ratio should always be less than B by 2H and greater than coefficient of lateral friction, or less than B by 2H and also less than coefficient of lateral friction, or greater than V by 2H and less than coefficient of lateral friction, or greater than V by 2H and also greater than the coefficient of lateral friction. Think about it. This topic is being explained in the video of revision of highway geometric design in the starting only. You can go to that video and you will find the answer there. The answer is, it is less than V by 2H and also less than coefficient of lateral friction. You can watch it here in that video. B by 2H value, this B by 2H value is less than coefficient of lateral friction, and thus the centrifugal ratio, that is the impact ratio, whose value is P by W, that is V square by GR. This P by W or V square by GR, this value is also less than this F, that is V square by GR. You can watch it here. For no skidding condition, it is less than F, and for no overturning, this is less than B by 2H. Okay. So this centrifugal ratio will be less than B by 2H as well as less than coefficient of lateral friction. Okay. Memorize it and watch this video if you find this video suitable for your preparation. Next question. The most efficient traffic signal system is simultaneous system, alternate system, flexible progressive system or simple progressive system. Just think about it. Most efficient traffic signal system in all these, it will be flexible progressive system. Flexible progressive system is most suitable type of. Usually in the exam, traffic signal system are not being asked, but we should memorize these things, that the most efficient traffic signal system is flexible progressive system. Next question. The terrain may be classified as rolling terrain if the cross slope of the land is up to 10%, between 10 to 25%, 25 to 60% or more than 60%. Think about it. What will be the answer? This is very easy question. We all should memorize it. It will be in between 10 and 25%. That is option B will be the correct answer. Rolling terrain between 10 and 25, plain terrain 0 to 10, okay, and mountainous terrain 25 to 60, steep terrain more than 60%. This will be the classification of terrain. Okay. Next question. Rigidity factor for a tire pressure greater than 7 kg per centimeter square is equal to 1, less than 1, greater than 1 or 0. Think about it. What is rigidity factor? I have explained about rigidity factor in the video of pavement design. You can go to that video from the link given in the description box. Rigidity factor for a tire pressure greater than 7 kg per centimeter square is less than 1. What is rigidity factor? It is the ratio of the contact pressure to the tire pressure, which is defined as rigidity factor. The value of rigidity factor is 1 for an average tire pressure of 7 kg per centimeter square. Now, the rigidity factor is higher than unity for lower tire pressure and less than unity for tire pressure higher than 7 kg per centimeter square. So this is also important. We should memorize it. This can be asked in exam, that rigidity factor for a tire pressure greater than 7 kg per centimeter square is less than 1. Next question. Reaction time of a driver increases with increase in speed, decreases with increase in speed, or is same for all speed, or none of the above. Just think about it. This is a very easy question. Obviously, if the speed will be higher, then the distance traveled in a particular time will be more. So if we fix a distance that has to be traveled, let's say this is SST only, then the reaction time will be lower in that case. So obviously reaction time of a driver will decrease with increase in the speed. Next question. For rapid curing cutback, the oil used is gasoline, kerosene oil, light diesel or heavy diesel. Think about it. For rapid curing cutbacks. In case of rapid curing cutbacks, we use the oil as gasoline. That is option A will be the correct answer. This is a picture of rapid curing cutbacks. Here you can find it out that these rapid curing cutbacks, these bitumen are said to cure as petroleum solvent evaporates. You can watch it here, the evaporation of petroleum solvent. The rapid curing cutback bitumen products are prepared with light, rapidly evaporating diluents such as naphtha or gasoline. Okay, so these rapid curing cutbacks, in this the oil used will be either naphtha or gasoline. Okay, so here A will be the correct answer. Next question. Dead slow is a regulatory sign, warning sign, informatory sign or none of the above. It is a type of regulatory sign. You can watch it here. Dead slow looks like this. Dead slow is a type of a regulatory sign. And what are regulatory signs? Regulatory signs describes a range of the signs that are used to indicate or reinforce traffic laws, regulations or requirements. Okay, these are the regulatory signs. We have explained about all the signs in the video of revision of traffic engineering. You can watch it from the link in the description box. Next question. The aggregate required for 1 kilometer length of waterbound macadam road per meter width and for 10 mm thickness is 8 cubic meter, 10 cubic meter, 12 cubic meter or 15 cubic meter. Think about it. Can you answer it? These all are being given in the schedule of rates of construction of WBM or different kind of pavements. So in this question the answer will be option C, that is 12 cubic meter will be the right answer. This is not so important question, but one should watch it because it was once asked in an exam of state services only. That is why it is being kept here. Okay, next question. Length of a vehicle affects width of traffic lanes, extra width of pavement and minimum turning radius, or width of shoulders and parking facilities, or clearance to be provided under structures such as overbridges, underbridges, etc. Think about it. First of all, think about this last statement, clearance to be provided under structures such as overbridges, underbridges, etc. What will affect it? The height of the vehicle, that will affect it obviously, because the clearance will be affected by the height of the vehicle. Okay, now width of the shoulders and parking facilities, so obviously the width of a vehicle will affect it. Now extra width of pavement and minimum turning radius or width of the traffic lanes, obviously width of traffic lanes, it will be affected by width only, so answer will be only the extra width of pavement and minimum turning radius. Now how it is so, let's find it out. Option B will be the correct answer. Here we can see in the formula of extra widening, in this extra width equal to NL square by 2R plus V upon 9.5 under root R. Here we can see that this is L, that L is the length of the wheelbase of longest vehicle. It will affect the extra widening of the pavement. Okay, so first of all, it will affect the extra width of pavement. Now the turning radius you can watch here, turning radius will also be affected if the length will be higher. If the length of the vehicle is high, then obviously the radius of the curve provided, that will also be high. Okay, so that is why it will affect the minimum turning radius also. Okay, next question. In hill roads, the side drains are provided only on the hill side of the road, only on the opposite side of the hill, on both sides of the road, or none of the above. Think about it. On which side the side drains are provided? In this, the side drains are being provided on the hillside, that is only on the hillside of the road. Option A will be the correct answer. You can watch it here. These are the side drains which are provided on the hillside. This is the valley side, this is hillside. So it will be provided on the hillside only. Okay, drains are provided on the side of the road is called side drain. Side drains runs parallel to the length of the road and its function is to collect and drain off the rainwater collected from the camber of the road. Okay, so if we have to collect the water from the camber of the road, so we have to collect it in the drain like this. Okay, it has to enter to the side drains. Next question. If the group index value of the subgrade is between 5 and 9, then the subgrade is treated as good, fair, poor or very good. Do you know the range of values for these? If you know, then only you can answer. So group index value of 5 and 9, it will be for poor category. Okay, you can watch it here, type of the subgrade. For good it is 0 to 1. Lower the value of the group index, fair will be the subgrade type. For fair it is 2 to 4, for poor it is 5 to 9, for very poor it is 10 to 20. Okay, and you can watch it here that group index value ranges from 0 to 20. This is also important question, you should memorize. Group index value varies from 0 to 20, and from 0 to 20 you can watch that it will deteriorate. The subgrade type will be of lower quality. Okay, next question. The shoulder provided along the road edge should be rougher than traffic lanes, smoother than traffic lanes, of same color as that of the pavement, or of very low load bearing capacity. What will be the answer? Just think about it. The shoulder, at the shoulder, first of all, it should be rougher than traffic lanes. Obviously it should be, because the traffic that will be stopping there, that has to stop and move from 0 speed. So that is why we have to provide rougher than the other traffic lanes. Okay, it cannot be smoother, it can be rougher only. Now of same color as that of the pavement, obviously we will not provide of the same color, so that there can be a distinguishment between these two. And of very low load bearing capacity, which is also not correct. The load bearing capacity should be same as that of the pavement, because the traffic is same for both main pavement as well as the shoulder. Okay, so the shoulder portion, this has to be rougher than the normal surface of the pavement. Okay, next question. With increase in the speed of the traffic stream, the maximum capacity of the lane increases, decreases. First increases, then decreases after reaching a maximum value at optimum speed, or first decreases and then increases after reaching a minimum value of optimum speed. What will be the answer? Just think about it. If we increase the speed of traffic stream, then what will happen to the capacity? Think about it. Here we are talking about the capacity, means the volume of traffic per hour. It will, first of all, if we increase the speed of traffic, then it will increase. So it is true that first of all it will increase, but there will be an optimum value. After reaching a maximum value of optimum speed, it will start decreasing. Okay, you can watch the graph here. This is the graph of speed versus volume. If you increase the speed, then the volume will increase, and after reaching an optimum speed, this is the optimum speed. Now what will happen? The speed is being increased, but the volume is being decreased, because the distance between the vehicle will be increased to very high value. Okay, so that is why it will decrease. Next question. With increase in speed of traffic stream, the minimum spacing of vehicles increases or decreases. First increases and then decreases after reaching a minimum value at optimum speed, or first increases and then decreases after reaching a maximum value at optimum speed. Think about it. We are talking about minimum spacing of vehicles. So we are talking about, this time we are talking about the density. Okay, if you increase the density, then spacing will be reduced. If you reduce the density, then the spacing will be increased. So if we increase the speed of traffic stream, what will happen? Let's see. Option A will be the correct answer, that the minimum spacing of the vehicles will increase. How it is so? Let's find it out. With increase in this space mean speed, you can watch that the value of density is being decreasing. It will reach to an optimum value, that is the jam density by 2. Jam density will occur when the speed will become 0, when all the vehicles are being stopped. In the case of the jam density, the distance between the vehicles will be minimum. While in case of the free flow of the traffic, when density is very less, or we can call it density is approximately reaching to 0, at that time the distance between the vehicles, that will be very high. Okay, so if we increase the speed, then the distance between the vehicles will increase, because the density is being decreased. Okay, we have explained this concept very well in the video of revision of traffic engineering. You can refer to this video from link in the description box. Next question. For waterbound macadam roads in localities of heavy rainfall, the recommended value of the camber is 1 in 30, 1 in 33, 1 in 48 or 1 in 60. This is the question which we have to memorize. There is no other option. The recommended value of the camber will be 1 in 33. it is option B will be the correct answer, and this is the table for it. In this we can find out that WBM and gravel pavement, for heavy rainfall the range of the camber will be 1 in 33 or 3%, and for low rainfall it will be 1 in 40 or 2.5%. For the other cement concrete, thin bituminous surface and earthen road, these values will be adopted for the cambers which are given in this table. Okay, memorize it by pausing this video. I am moving further. Next question, maximum number of the vehicles can be parked with parallel parking, 30-degree angle parking, 45-degree angle parking or 90-degree angle parking. Think about it. We are just talking about the maximum number of vehicles. There is nothing optimum or something is being asked. There is no restriction of the width also. Then what will be the condition in which maximum vehicle can be parked? Obviously it will be parked maximum at 90-degree angle. You can watch it here. At 90-degree angle there will be maximum amount of the parking, while at some angle you can watch it at some other angle like 30-degree, 45-degree, there will be less amount of traffic that can be parked. Okay, so maximum it can be parked in case of 90-degree, but it is not the optimum because it will require a higher width than the rest of the type of the parking. Next question, the stopping side distance depends upon total reaction time of driver, speed of vehicle, efficiency of the brakes or all of the above. Just think about it, very easy question. The stopping side distance, it will depend upon all of these. You can see it here that it will depend upon the reaction time of the driver, that is Vt plus V square upon 2gf plus n by 100, as well as it is dependent upon the speed of the vehicle also. It will depend upon the efficiency of the brake also, okay, which is not being mentioned in this formula. It is very much applicable with efficiency of the brake also. So the answer will be option D, that is all of the above. Okay, next question, most suitable material for highway embankment is granular soil, organic soil, silts or clays. Think about it, most suitable material for highway embankment, what it will be? It will be granular soil. We will prefer granular soil in case of the highway embankments. Other kind of soil are not being preferred. They can be easily washed away in case of the fair amount of the water. Next question, which of the following represents a carpet of sand-bitumen mix with coarse aggregate? Mastic asphalt, sheet asphalt, bituminous carpet or bituminous concrete? Think about it. We are talking about the carpet of sand-bitumen mix. What will be the answer? It will be called as sheet asphalt. This is called as sheet asphalt. It looks like this. Sheet asphalt are a carpet of sand plus bitumen, mixture of sand and bitumen. Okay, memorize it. It is also important. Next question and last question of this video. The desirable length of overtaking zone as per IRC recommendation is equal to overtaking side distance 2 times the overtaking side distance, 3 times the overtaking side distance or 5 times the overtaking side distance. Think about very easy question. We should know the answer because it is very important question also. The desirable length of overtaking zone, it will be 5 times the overtaking side distance. Usually this value ranges from 3 to 5 OSD. Minimum length of overtaking zone, that has to be 3 times, and desirable length of overtaking zone, that has to be 5 times of OSD. So it will be option D. Okay, so here we will finish this video. In the next video we will come up with question number 31 to 60. Till that, subscribe to this channel and stay updated.